And welcome back. As we go ahead and dive deeper into our algorithms, let's go ahead and look at how we can start applying these to sorting by first looking at something known as the merge sort. So we of course have discussed the sorting pattern, and the simplest realization of this pattern is the merge sort. In this realization, the array-based type is specialized to the type double. The merge sort is an example where our definition of split is very simple. So the splitting algorithm part of it is pretty simple, because what we're going to do is we're simply just going to take that array, divide it into two intervals with no rearranging of elements. Now our join method, where we have to put these lists back together, is going to be a bit more complicated. So let's work through the algorithm just a little bit here. After our two subintervals are sorted, the method join will merge the two sorted subintervals, copying elements from the array to a temporary array. The merging starts by comparing the smallest element in each smaller sorted interval, and the smaller of these two elements is the smallest of all elements in either subinterval, so let's move to the first position in that temporary array. The process is then repeated with the smallest elements in the two smallest sorted intervals to find the next smallest element, and so on and so forth. Now, obviously, there is some trade-offs that we have to discuss here when using this approach. One of the things you'll notice is there is a complexity between the methods split and join. You can make either one of them simple at the expense of making the other more complicated. For our merge sort algorithm, the split method is going to be fairly simple, and the join is going to be much more complex. So let's go ahead and take a look at that here in our example. Alright, and so if we take a look at our merge sort example here, you can see here's our sorting algorithm, which is pretty much very simple and similar to what we have seen before, because, we're taking it, we're finding our split point, we're sorting it, and we're joining it. Straightforward. However, if we look at how the split and join works, split is very easy. It's simply looking for the midpoint, so beginning plus the end, divided by 2, and is returning where that split point is going to be. Now, if we look at the join method here, you can see, again, we have a little bit more complexity, because you can see here's our temporary array. We're having the size of the interval. We're setting temp then equal to a new array of whatever the interval size is. And then, of course, we want to find out where is the next left and the next right, so we can find those split points. And we, of course, need to just have this index I here, which is just a kind of index for a temporary array, so it knows where to start. Then, of course, we can loop through this. You can see we have quite a bit of loops working through. We're going to merge until one side is exhausted. So you can see it works all the way through, and there's a lot of iteration that goes on here. No recursion, really, as you can see here, because we don't have a call to the joining method here. All right, but then, of course, if we complete one side completely, we, of course, can copy the rest of the left chunk, if any, and then copy the rest of the right chunk, if any. And you might say, well, this doesn't seem too bad. But again, if you just look at the complexity of this code in comparison to our split method, you can see how that can be more complex. Now, what does this look like if I actually want to call it? Well, calling it is fairly simple. Here I have a unsorted array, and I'm just going to print those out. It's like, here's the array contents we sort of sorting. I'm going to print them out. And then I'm going to call the sort algorithm to go ahead and sort those array values. And again, if you look at here, split and join are, of course, in this case, two methods that are private. All right, we don't actually have access to it. The only thing we, as a user, get to call is sort. We don't have anything in here. Like if you look at, for example, where join is, notice there's no recursion call in here. All right, other than we call this method here. So where does that recursion happen? Well, it happens here actually within the sort method itself. So the sort method is what's calling it. So just keep that in mind if you start thinking about how are these algorithms actually working, how are they actually invoking one another. The recursion doesn't happen here in join, it happens here in sort. So if we look at that sort call, what it does after it sorts it prints them out. So let's just give that a quick run. And we get the array contents before they are sorted, and then after they are. Now you notice it is a little jumbled here, so one thing we could do, of course, is add a little space in here. And notice there's no space. Let's just do a tab in there, just so we can make sure these are a little bit easier to see. And I'm just going to rerun that just so we can see it a little bit nicer. There we go. So we got 7.7, 5.5, 11.0, 3.0, 16.0, 4.4, 20.0, 14.0, 13.0, and 42.0. And of course, you see they are now sorted because they're going from least to greatest. And again, that's all happening here in this merge sort class. So this, of course, is one of those approaches, which is we say, hey, here's our split algorithm. Make it simple, which means our join is going to be more complex. But what if we switch that around? What if we decide, you know what if our split is much more complex and we have a much more thorough split approach in order to make our join simpler? Because remember, that's a trade-off. One has to be, more complex than the other. That's the trade-off that we're looking at here. And so we'll actually take a look at that next time with a different sorting algorithm so we can go ahead and see how that implementation might look.